The idea of continuity or a continuous function is very useful in something we call the intermediate value theorem. So let's imagine a couple functions. So imagine that we're going to graph the temperature of a cold winter night, all right? We've got our horizontal axis of time, our vertical axis of the temperature, if you can imagine that. And let's say that we knew that at some point it was like a record low of negative 18.3 degrees Celsius, all right? And it later warmed up to 5 degrees Celsius in that day there. The question is, was it ever exactly 0 degrees? Well, we can also ask if it was pi degrees. Was it 3.14159 degrees, exactly pi degrees? Did that ever happen? Well, since temperature is continuous, then we know that at some point the temperature had to climb from down at negative 1.83 all the way up to 5 degrees. So it had to pass somewhere. We don't know where, we don't know when, but it had to happen. Here's another one. How about my daughter Emily, who was 46.5 inches tall? You can see over here on the height gauge. This is a picture from our closet where we used to measure how tall our kids were. And so on 8/30/2010, she was 46.5 inches tall. And she was 48 inches tall on January 4th, 2011. So, question I might ask is, was she ever exactly 47.25 inches tall? And, well, she'd have to be, right? Because at some point, because growth is continuous, it might have happened in the middle of the night. I don't know if when you were a kid, you ever grew like a whole inch like our kids did. It seemed like they grew an inch overnight. But at some point, you had to pass through every height. And so that's because height is a continuous function. So this is what we call the intermediate value theorem. And we can be sure of this because the functions are continuous. If the functions aren't continuous, then maybe it jumped. But since they are continuous, we know that it had to cross every point in between. And that's the intermediate value theorem. Let's check out a couple more examples to see how this intermediate value theorem works. So this intermediate value theorem says if we've got a continuous function on a given interval, and we know an f of a is not equal to f of b. So we've got, again, that separation going on here. So we've got 2 points at different heights, okay? And we can be sure that if this is A and this is B, then this is f of. Then if for some f of c, you pick any f of c, in other words, any y value, in between, then at least once it had to cross that. Now, it might have crossed that more than once. There might be more than one, but we know that there's at least one value, one x value that has that y value. Okay, anyways, that's the idea. All right, so let's look at a couple of problems. These are AP problems that use the intermediate value theorem. We got a car traveling on a straight track, and during some time between t equals 0 to 60, the car's velocity v is measured in feet per second and acceleration a measured in feet per second per second. And these are continuous functions. That's important. If they're not continuous functions, then this doesn't work. And by the way, that's a clue that we're going to be using intermediate value theorem. So the question is, if we have these values in the table, then was there a time t where the velocity was negative 5? Well, here's what we need to say. If we look at velocity here, here's our velocities. It went from negative 20, which means we're moving left, all the way up to positive 10. Was it ever negative 5? Well, negative 5 is in between these. So we're going to look at these two values, and we can say, since we know that v of t is continuous. We've got to state that. If we don't say that it's continuous, then our argument does not hold. But since v of t is continuous, and we can say v of 35, because that means that 35 seconds is negative 10, and v of 50 is 0. And we'll throw in there this, that's too many ands, don't tell my English teacher there. We know that negative 10 is less than negative 5 is less than 0. So negative 5 is between those. Okay, we can say by the intermediate value theorem, which we can abbreviate IVT. That's a very standard abbreviation there. By IVT, there must be a time t between 35 and 50 seconds where v of t is exactly negative 5. All right? So, we need to state it's continuous. We need to state that we know that there's a velocity less than and a velocity greater than. And we need to say the word IVT, or the words intermediate value theorem. And we can say that there's a time t between 35 and 50 seconds, because those are our x values here. All right. So that's the idea there. Let's try one more AP question. Here we have a table of continuous functions. This is not necessarily a car or anything like that. But we just know that we got continuous values, or values of a continuous function. Again, that's a clue. Once you see that if you're doing the AP test or AP questions, you know it's a continuous function. Our brain should start thinking intermediate value theorem. For x between 0 and 13 is what's given. So the question is, what's the fewest possible times that f of x could be 4? Well, this is a continuous function. If it helps, you can kind of sketch a little graph of it. So when x is 0, we're at 3. When x is 4, we're at 4.5. When x, and so 4 is right in between here. That's important. Okay. When x is 6, we're back down below, somewhere here, below 4. When x is 8, we are down lower, 2.5. When x is 13, somewhere out here, we're back up. So this function has to go somehow up, and then somehow down, and a little farther down, and then going up. So everywhere that we cross 4, there's one there, there's one there, and there's one there. So at least 3 times, okay? So since it's continuous, and we could say something like this, f of 0 is less than 4, and which is less than f of 4. And we got f of 4 is less than 4. Actually, I should say greater than 4. Let's get this right. F of 4 is greater than 4, and f of 6 is less than 4. So that's kind of our other in-betweener there. And then one more, we've got, we got f of 13, right? So we got, in other words, we got these 3 intervals, all right? A couple ways to say this, but 4 is in between there. The fewest number of times must be 3. So the fewest
number of times that and our reason for that is by the intermediate value theorem, and we've justified it using the fact that it's continuous and using these. All right, so last thing we'll say on this, and then we'll wrap it up. It is possible that we could have more, because this could go up and down and up, down and back up. So we could cross a whole bunch in there, but it's got to cross at least once. And that's important to understand. The intermediate value theorem says it crosses at least once when we have a value below and a value above. All right, so when we know it's continuous, we know that all the y values between the two y values given must exist. That is the intermediate value theorem.